In this video, I'm going to work very slowly through a data set and look at how we would summarize each of the variables. This is not necessarily a video that everyone needs. It's just for anyone who's feeling a little bit overwhelmed by all the graphs and the different numbers we can use if you haven't studied these a lot previously. So we'll just be looking at doing bar charts, histograms, box plots, and summary statistics, counts, percentages, mean, standard deviation, median, those sorts of things. And we're going to work out how we decide to summarize each of our variables. Now, I'm not going to use the data that we are using for the activity in class because I would like you to have a fresh set to think about. I have found another data set on students where a slightly more well-designed, rigorously designed experiment was conducted. Not that I think there was anything wrong with our class experiment. However, this is available on the internet. I will put a link in with the video. I'm not going to sort of analyze the data and look at the comparison. I'm just going to look at how we summarize each variable. So the experiment was about exercise intensity and verbal spatial working memory, which sounds fascinating, unless it means that I have to start going for a run before I do any intense mental work. We'll see. I'm not even going to read their summary too much because we're just going to take a look at the data and see how we would think about summarizing it rather than looking at their summary, which I'm sure is perfect. So I will put a link below. I have the data open in Jamovi and I can see the first few columns. So we have ID, age, sex, group. So fairly similar categories to what we did in class. BMI, heart rate, don't know what IPAC is, and then they've got they've got a few other variables, but I mostly would like to look at, say, the first 4 or 5 columns, and we'll take a look at these and see how we would go about summarizing them. So we don't really need to summarize the ID variable, except we may be interested to say how many there were in total that participated in the study, which it'll pop up probably in a lot of the statistics that we see. So it looks like there were 78 students who participated. So we could write that into our summary. Students who agreed to participate. And now we want to start working on a table of these variables. So we're going to go through and list the types of variables and the graphs we might use and then how we might summarize them. This is not the kind of table that would actually go into a final report. You would condense it right down to just the key information, not the process that you went through. But for the sake of the activity, so that we're all on the same page, how big do we need this table to be? That's probably big enough. We can change it as we go. So we're going to put in the variable and we're going to put in the type that it probably is. And it's always possible that you change your mind after looking at it. And then we're going to look at the graphs that we would start with. And then we might make a note if we change them, the summary statistics, and maybe a conclusion or a written summary. So the first variable, we're not going to bother summarizing, that was just the ID. The next one is age. So typically age, I say typically, it can be anything. Sometimes we measure it in a continuous way, sometimes we measure it in categories. For the sake of argument, let's say we're not really sure and we're just going to assume it is a continuous measurement, and then let's see what we would do with this. If it's continuous, we would probably start by looking at a histogram and a box plot. So if I go over to Jamovi and we take a look at age, currently it's listed as nominal. Now it's definitely not named categories. So this means that Jamovi hasn't been able to interpret what it is. So we're going to fix that up before we do anything else. So I'm switching to the data tab and going to set up. And I'm going to tell it that it is continuous, although it's possible we may change our mind and put it as ordinal in a bit. And integer is fine. Now we are ready to describe it. So I'm going to go to analyses and exploration, descriptives. So if we just put age in here, and I'm not going to split by another variable, but it's possible that you might want to split by the treatment group if you want to see if the ages were similar in the control and the intervention group, or we don't even know how many treatments he had yet because we haven't got to that bit. So we have 78 in total, a mean age of 19.1. That doesn't really tell us a lot if we don't know what the shape of the data is. A minimum of 18 and a maximum of 22, so there's not a lot of variety. Let's open up the plots and do a histogram. So they're mostly 19. And we could do a box plot as well. If you get an odd-looking box plot, it could mean that either you don't have a continuous variable, it could mean that you've got very little data, it could mean that you've got very little variation in the data, which is kind of what we have here, in which case it's not especially useful. So the median is 19, so the middle person, if we lined them all up by age, the middle person is 19 and the average age is 19.1, so it's pretty similar. Because this isn't approximately normal, if we gave a mean and a standard deviation, it would sort of imply that most of the participants were within sort of 3 standard deviations of the mean, and that's way too broad. That's not who was in it. So I think this is a case where we could treat this as ordinal and give the counts, and possibly we could combine these age groups 20, 21 and 22 together. So if I go back to data and setup, let me tell it that it's ordinal now. And what I do quite like about Jamovi is that when you click on a bit of output, it takes you back to the place where you did it, so you can immediately go back to your dialogue. And let's ask it for is it going to count it for us? Frequency tables. Here we've got the counts. So technically, if we've got counts, we wouldn't have a histogram anymore. We would have a bar plot or bar chart. I don't know why, but plot feels really funny to me with bar. I would say a bar chart. I don't suppose it matters. And we could group these ones together, or these last 3 together if we wanted to. So that's the thought process I've gone through for that variable. So we could put a little note, ordinal, maybe group higher categories, higher ages. They're not technically categories. Nope, using a bar chart instead. Now, there's not necessarily one correct answer. It's possible that different people may look at the same data and decide, oh, I've already said it was students in a first year class. No one's going to get misdirected by a standard deviation and think that there were more students or something. So it's possible that people can come to different conclusions, and that's fine. So our summary statistics would be counts and then a percentage in brackets. And I won't go through and write them all out, but you could create a separate table where you actually write the summaries in. And as that one has only got one person in it, I would definitely group that. We would usually do that for privacy, if nothing else, because that feels very identifiable to have one person in a group. So I would definitely group the 21 and the 22 together, and I might even group them with the 20-year-olds. Not entirely sure that age is going to make this much of a difference at for this type of experiment when they're all so young. Next variable, let's go back to our data. So we have sex, which was probably actually gender. So sex is usually biological sex and gender is how people identify. If they've done this with a survey, I'm guessing they mean gender. if it's medical data and it is actually referring to biological sex, then that would be fine. So this is nominal. I'm going to guess that they've only used 2 categories, which is fine. So often a third category would be very, very small and potentially not useful in a statistical sense. So if we want to summarize this, we would definitely just want to count it up. Let's have a look at a bar chart. I guess I can write that into my notes first. So I'm going to stick with what they've written for consistency, and it is nominal, and we would do a bar chart, and we will want counts and percentages. So exploration, descriptives, and the sex and the frequency table, and a bar chart. So nearly evenly split, which is quite nice. So there's our counts, there's our percentages, and we can pop them in, and that's an appropriate graph. Hopefully that was an easy one. What's next on our data? Group. Well, we can already see that they had more than one group. So these will be the exercise groups or the intervention groups, because they were doing something about exercise and working memory. So we could call it exercise groups, intervention groups, experimental groups, something like that. I haven't read the paper and I know no details. So it's possible that this is an ordinal variable and that each number represents an increase in exercise intensity, so that there is like an order to the groups, but it's possible that they are just variations. They're just different types of exercise and it's nominal. So because I'm not sure, I'm just going to treat it as being nominal, and I'll do a bar chart. And again, we're going to want counts and percentages to summarize it. So analysis, exploration, descriptives. I don't know what those labels are. We probably should read some details. I'll let you read the details of what they did and tell me in class. So let's have a look at a bar chart. So they had a fairly nicely designed or balanced, fairly balanced. It's not perfectly balanced experiment. We've got a few more in group 4. So maybe they sort of allocated everyone to the 4 groups and then they had a few extra and they're like, you can join in with control group. I'm going to guess that CG is the control group. Low, moderate, high. So maybe this is, what's G? I don't know if that's G for group or something else. So I'm going to guess that this is a control group, low, moderate, and high exercise groups. I could be wrong. Now, we don't want the mean. That's not going to be helpful. So you do have to be aware when you're using a stats package that sometimes you're just going to get default options ticked off and it will give you information that you don't need. So either untick them or just ignore the bits that you don't want, but we definitely want these counts, and we can see that there's 19 or 21 in each of them, and then the percentages. So this is the information that we want here. Next variable, BMI. So they presumably measured weight and height and calculated it, possibly they asked them to do this at home. I'm not sure I would ask students to do this, but maybe you could as part of a proper research study, but I wouldn't as a class activity. So this is continuous. So we will have a look at doing a histogram and a box plot, and then we will decide what to do with it. So typically with a continuous variable, you would summarize it with the mean and the standard deviation, unless it's very skewed or got a lot of outliers. Something that would mean the mean and the standard deviation may be a little bit misleading, and then you would probably use the median and the quartile 1 and quartile, well, 3, and you might use the min and the max. I don't think I need all these columns. I could have done with fewer. So let's have a look at it and then we can make a decision. So in the analysis, exploration, descriptives, and we will do the BMI. We do not need a frequency table. We are interested in, first of all, in a histogram and a box plot. It looks pretty symmetric, actually. That's quite nice. Oh, perfectly. So if the mean and the median are both at the same point in the middle, then it means we have symmetric data. We don't have any outliers that I can see, and it looks approximately normal. So this would be one where I'm quite happy to use the mean and the standard deviation. It's not perfectly normal. It looks like we've got a little bit of truncation, like we don't have any very low BMIs and we don't have very high BMIs, and that just might be down to where the study was conducted. If this was conducted in exercise students, quite possibly they are all within a healthy BMI range. And it's also possible that they didn't want to have anyone in the study if they weren't in this narrow BMI range. So there's reasons why you might get the restricted range. But for the purposes of summarising it, I would be happy with the mean and the standard deviation. So if we bring up the table again, I don't want to delete anything. Maybe I'll just highlight the one that I chose. I can't use Word today, apparently, for some reason. All right, we'll do one more. We might do two more, depending on if we find anything interesting. Oh, heart rate. Let's take a look at this. So this is, it's discrete in that you get a beats per minute, but it kind of, I'm guessing it behaves as if it was continuous, and it might look normal, it might not. I haven't looked at heart rate data in a long time. So let's set this up and change this to being continuous. It's probably all very healthy heart rates as well, because we've already seen what their BMIs are. So I'm guessing we don't have anyone with a racing heart or crazy low. Oh, could be very low resting heart rate. I don't know why I've kept my window there, but I'll leave it there. Heart rate, and I'll just do histogram. Again, it honestly looks like a triangle. It doesn't really look normal, but I would be happy to summarize that with the mean and the standard deviation. So it doesn't need to be perfectly normal. We're just looking to see if there's anything very skewed or a lot of outliers or anything that might distort the mean or how we interpret the two numbers. But if it looks like this, then that's an approximate summary. That's fine. So a normal distribution would probably be less like a triangle, and it wouldn't have this peak so much, and it would sort of come out a bit more, but we're sort of in this restricted range. So what else did we have here? We had the IPAC. Let's take out the heart rate and just put in the next one to have a look. Now this one is a little bit skewed, and they've got one little outlier popping up at the bottom. So you could choose to summarize this with the median. The median is the line in the box plot, and we can put the mean on it with this tick box here, and we can see that the mean has been pulled away from the median. So that's the effect of this, what we call longer tail and outlier, is it's pulling on the mean. So you could choose to summarize this with your median and your quartiles, and I think this is going to give it to us. So we would want the 25th and the 75th, which is this line here and this line here, so the ends of the box. I was just trying to work out what, I feel like I should know what IPAC is, but I have no idea what that is. IPA questionnaire, I don't know. I'm saying all of this hesitantly, not because there's anything wrong with summarising it with the median and the quartile 1 and quartile 3, but just because it's so common to summarise everything with a mean and standard deviation. Don't be surprised if they just use that for everything. And it's not horribly skewed. This is just a little bit skewed. So it's not a huge concern. But I think this would be a nice example where you could do something different with it. Let's have a look at, so the VO2 max, that's your oxygen intake, uptake, isn't it? So I feel like that should be continuous. Let's go back to the data window. And let's change that to continuous and see what it looks like. I'm going to take that one out. The only downside to taking them out and putting the next one in is that it will sort of redo the analysis, whereas before when I was clicking out and clicking back in, I've saved it all. So, but it really depends whether or not you want to save it or whether or not you're happy just to leave it there. I can probably put them all in at once, can I? I can, and it will just keep doing them. So this one here, it's a teeny tiny bit skewed. We've got what's called a truncation on the left-hand side. So it looks like it's been cut off. So there's a lower limit on the values. I don't really know enough about how this is measured or what it is to know why that would happen. So this might be one where we do summarise it with a mean and standard deviation and maybe give the min and the max if that's relevant in the context. But it's not horribly skewed. It's only a teeny tiny bit skewed. It's just not quite normal. Let's look at a few more just to see if there's any really skewed ones we can comment on. We have a few outliers in this one, but again, it's not horribly skewed. This one is more interesting perhaps because it does kind of feel like it's clumping into a few groups, and I don't know how important that is. If we changed the bins of the histogram, that would all smooth out, so it wouldn't be a problem. So I'm guessing that mean and standard deviation has been used for this one. Even though it is a little bit skewed, it feels like it's just a bit of an oddity. But just in terms of summarising the variable, that would be fine. Hopefully that was helpful. That would be my thought process. There's not always a single correct answer with how you summarise a variable. People tend to default to the mean and the standard deviation with continuous variables. But if there is something a little bit wonky about it, skewed outliers, then it may be more informative to give the median and the quartiles instead.